Nossa segunda sessão, o horário começando agora, a gente vai mudar para o idioma inglês. Nosso tema aqui é Smart Cities, a iniciativa sobre Smart Cities INCOSE internacional. Ok. In our second session tonight, I will switch to English. Jennifer, can you hear me well? Okay. Everything okay? Yep.
All well.
Perfect. So welcome INCOSE Brazil conference. Take the time here. Put your biography here. I'll make a small introduction to our present. Jennifer Russel is a EISE. ESAP is the program and management support leader on Graves Water team. Over the past 25 years, she honored her West Point leadership motto of being a leader character. From strategic planning and tactical logistics, Jennifer has invested in a public service and infrastructure. Currently, Jennifer is the chair of the INCOSE Smart City Initiative and has been the water director for the Transportation Working Group. Jennifer holds the BS in Engineer Psychology from United States Military Academic and MS 2003 and Engineer Degree 2007 Industrial and Systems Engineering from University of Southern California. So, Jennifer, you have 40 minutes, and at the end of your presentation, you have 10 minutes for questions. So thank you again. And the presentation is with you now. Good luck.
Fantastic. I am so grateful that you have all invited me here today to talk with you a little bit about our Smart Cities Initiative that is ongoing within INCOSE. Can you see my slides okay?
Yes, perfect.
Okay, fantastic. First, thank you for listening in English instead of Portuguese. I wish I could speak in Portuguese, but I cannot. So I am very grateful that you will listen to me for a little bit of time. But I'm really excited to be here and share with you what we have done and what we are working on with our Smart Cities Initiative inside INCOSE. So I'll give you quite a bit of background and we'll go into what is happening within our group. And of course, you can check on the QR code that will take you right to our website and you can see what's going on with our group. So smart cities is a very large space, as I see you just heard quite a bit about technology and some of the innovation that's happening around within the smart city space. And so INCOSE decided a few years ago that it would be beneficial to start understanding what was happening in the space and see how we could contribute some of our systems engineering skill sets. So we started looking at the industry and recognized quickly that there was a wide variety of what was happening in the industry. In short, smart cities are a moving target. And a lack of the early success actually diminished the term smart cities. So in the late 2010s, we started to see about 2017 a lot of pushback from some cities that had tried to implement a smart city because they were working so diligently on applying the technology that it wasn't quite working at that point. So we wanted to acknowledge that. And that was a bit in the past several years ago. Since then, there's been a tremendous forward progress. And what we see now today, actually, this article came out last month about a digital twin representing the sewer facilities throughout Brazil, which I think is fantastic. So there's been a tremendous steps forward in the digital transformation, and it's happening in public infrastructure all around the world, and especially in Brazil. But even with that, we keep hearing stories about how too much technology focus is driving some smart cities away from those applications. And in Carlsbad, which is a small city outside of San Diego in California in the United States, the chief information officer there made a pretty bold statement that success in a smart city has nothing to do with the technology and has to do with the people. And it seems like there had been not enough integration of the people involved in the city and the people who would use the technologies in order to make them as effective as they could be. So we acknowledged that that was a challenge within the industry. And we also identified that there was no common definition of a smart city. As we started looking around and understanding what was in the smart city space, you can find the illustration of a smart city and the top 10 smart cities for consulting firms or technology providers. And all of these groups would propose which were their smart cities. But we could never find criteria about what defined a smart city, nor a common definition of what makes a smart city. And as we recognize, the smart city that's a small village in a rural area is going to be very different than the smart city that's Sao Paulo. So with that information, we moved forward as a group and determined that we wanted to set up what our purpose and goal for the INCOSE Smart Cities Initiative was. And our goal, unlike many of the other INCOSE working groups, is not necessarily to support specifically systems engineers doing the systems engineering, but we really want to look outside of INCOSE and see how we can influence the communities around us by providing concepts, applications, technology, and services that leverage systems engineering tools and principles. Our ultimate goal is to create a model that illustrates the resources within a city that enables interconnectivity, reuse, and consistency. So as we looked within INCOSE, we could see that there are so many working groups that have a lot of influence on some or many parts of a smart city system. Everything ranging from security and architecture, telecommunications to automotive. All of these working groups have functions and services that will be provided or currently are being provided within cities around the world. So within INCOSE, we have the resources and knowledge to really make a big difference in our communities. So we decided that we wanted to set up a specific plan for products that we were going to deliver as part of our initiative. And so our products started with our definition of a smart city. It's really difficult to create a definition of a smart city that would apply to those small villages and communities equally as well to our large communities and cities that have very different desires for technology, different needs for implementation, and certainly different regulations and a regulatory environment. So making a definition of a smart city was really an important challenge for us. We also wanted to define some metrics that could compare the smart cities in their current state. Again, regardless of whether it's a small community or a large community, the smartness of that community can be measured consistently and would make a big benefit to all of us to be able to understand how communities are benchmarked against each other and internally with themselves. So defining what those metrics were was our next big challenge. And we also have on our plate to develop a reference model that INCOSE supports to support a holistic perspective of smart city development. So these are our products. We have done that, and I'm really excited. Just this past September, we released our first product, and that is our Smart Cities Initiative overview. And within this product, you can find our definition of a smart city, which I'll review with us. You can understand how we came to develop our assessments and what should be happening next, what the next steps could be to work towards a holistic smart city initiative. And as we were going through and developing this, we recognized that we wanted to acknowledge humans at the center of the city. So many of the applications that we see for smart cities are really technology driven and solution focused. And in some cases, it's a solution looking for a problem. And we really said, you know, how can we integrate humans better into defining the smart city needs? So we found an economist who in the 1970s defined 9 fundamental human needs. And we believe that these 9 fundamental human needs are the foundation for a smart cities mission. This is slightly different than Maslow's hierarchy of needs, which you may have heard before. Maslow's hierarchy of needs really places food, water at the very base of their pyramid, and anything over that is going to be extra or maybe not even necessary. But we disagree. Humans live in community. We live in cities because we want some or all of these 9 fundamental human needs in order to feel whole and to feel like we are contributing to society. So these 9 fundamental human needs include subsistence, protection, which is clearly found within a city, affection, which we always get some good discussion because is a city responsible for affection? No, but within a city context, you can find other people and you can find the kind of environment where you can feel affection. Similarly with understanding and certainly participation, the ability to think freely and be creative in your thinking, to have identity and self-expression and freedom of choice of course, within the context of the domain and governmental structure that this municipality may exist in. But these are 9 fundamental human needs that we have taken as our baseline upon which the rest of our systems engineering solution is built. So with these 9 fundamental human needs, we took a really long time coming up with a definition of what a smart city is. And the way we have this organized is that these 9 fundamental human needs are the heart of the common mission of the city. But with that common mission, what is it that makes the city smart? So a smart city is capable of identifying its problems, number 1, mitigating those root causes by generating and processing engineered quality data in an inclusive and continuous manner. What I really like about our definition is that the first 3 steps have nothing to do with technology. The first 3 steps are the human portion of what happens within a city to identify the problems and mitigate the root causes. Those are human decisions. The generating and processing is where we get into the data and the technology solutions. And the engineered quality data in the continuous and inclusive manner, that's the recursive loop upon which the decisions that are being made by the humans should be made. So with this definition of a smart city, we believe that it applies to a small town that wishes to be smart, equally as well to a large city with autonomous driving, metered sewers, and all of the digital twin solutions that may be amenable or affordable for that municipality. So in order to develop and walk through our process, we believe that it should be a systematic process, that a municipality is a logical system, that it is built on logic and really is a system of systems. But breaking it down into those smaller subsystems really helps us understand the decomposition and recomposition of the city to make sure that the goals are aligned and the services being provided by the city really are aligned together. And so we have these set of steps that you walk through to derive the model for a smart city, and then tools that are able to support that. And once we get there, it looks like this, and we can see that a city is a system of systems. And so we can see our first cluster is we have the actual city itself. So you have a municipality, and then within the municipality, you may have an energy supplier. You also have educational services and residents and 27 other stakeholders that participate within each individual city. But if we look deeper into that energy services group, then we have energy producers, we have energy suppliers, we have the distribution system, and then on and on and on to break that down and further decompose that particular part of the city. And the power plant engineer then becomes part of that energy producers system. And so inherently, we have a system of systems within a city. And what we see oftentimes is that each group at level 2 is very good at managing its own systems and oftentimes has a well-established hierarchical prioritization, evaluation with metrics, and services that they're providing for their constituents. And there is some consolidation at the city level, but there's often a disconnect between the goals of the city and those services group who are providing all of those major services. And it's really difficult, and that disconnect is probably because it's really hard to get everybody to agree on one thing. And so oftentimes we find that challenge of having the disconnect is really where the root of the issue is, and we can offer a lot of support for a municipality. So in our development, we came up with a single set of holistic metrics that provide a consistent benchmark for evaluation and comparison of cities. So this single set of metrics, the 3 that you see in blue are metrics that are consistent for any smart city that we would evaluate. There's a holistic index, the TUS index, and that indicates how well the city is functioning together and meeting the common goal. The next metric is a systems property alignment. And this really is a measure of how well the city's top level goal or mission is decomposed down to those subsystems. And so with a metric, we can understand how well the communication may flow, how well the networks are aligned, how well the duties and performance of those system support elements are aligned within each city. And then finally, we have the system operations performance, which tells us how well the system is operating all together as a network. And those are unified. This is how we can evaluate the small smart city and the big smart city using the same set of metrics, because how well your goal is aligned within the city should not matter how big the city is. It doesn't matter. But it is a clear indication of how well the city can be functioning. So we also have a well-being index and a social responsibility index. These are tailored for each municipality and are based on ISO recommendations for smart city metrics and UN sustainability goals. So we definitely are tied in closely with the UN sustainability goals, and that is clearly reflected with a direct connection to our social responsibility index. A key element of our proposal and what we recommend is that once we get down to that fifth level of our definition of having the engineered quality data, it's necessary to identify and mitigate those root causes that you find of challenges within a municipality. And so the engineered quality data has these specific characteristics. It's real-time, verifiable, integratable, uniform, inclusive, aligned. With all of those characteristics, that qualifies as engineered quality data. But in short, what we're really looking for is to make sure that we're thinking about what we want to measure first, and then figuring out which data we need to measure it. Collecting all the data that exists in the world to begin with may not be the best solution and the easiest way to start. But by figuring out what you need to measure first, you can really start making a difference in performance and how people are responding and how the system is aligned. We also developed a framework that we want to use to evaluate and understand how the stakeholders within a municipality get along. So this is the INCOSE TUS reference model, and it is a robust, tailorable, and systematic way to view and evaluate a smart city as an integrated, complex social system. So what we see here is the shared common mission of the city at the heart that is decomposed out to each of the stakeholders. And we consider that all of the members of the municipality, be them members or employed by the city, or residents of the city, or service providers within the city, they're all stakeholders and reliant upon each other to provide those services. If we look at this and we take a closer look at how these are integrated, what we see is that we have a simple plan, do, check, act surrounding the common mission. And these steps, the plan, do, check, act, the planned results, the measurement, achieved results, and diagnosis, that feeds into each of the different stakeholders' actions and how they go about implementing them. If we break this down and understand what this means, what we see is that the healthcare services group may provide ambulance service to go out and provide emergency care for people in their homes or in wherever they are. But that ambulance service relies on the transportation network in order to provide that service effectively and efficiently. And so therein, that healthcare services group is dependent on the transportation system in order to be able to provide their service. And yet we don't often have a close connection between those groups to provide those services effectively across the city. And this framework would really help us evaluate and understand some of the connections between our stakeholders within a municipality. So that content is in our publication, our initiative that is available. You can find on the INCOSE website. But our daily work consists of three main focus areas. So really, we've spent a considerable amount of time lately working on the framework and collaborating with demonstration cities. We also have an IEC and INCOSE partnership where we are working together with them on their smart city reference architecture. And we also are working on some smart city use cases or solution architectures that will help us develop our model and understand how we would want to go about creating our reference architecture. So I'm really excited to share a little bit about some demonstration cities and what we've been doing on a day-to-day basis. We have been working with 2 cities so far. The first is the city of Ulaanbaatar, which is the capital city of Mongolia, and the second is the city of San Diego in California in the United States. In Ulaanbaatar, we have shared the framework that you can see and given some great presentations to their city elected officials and their business community. And so these presentations have helped them start to understand how their departments in this very old capital city are connected together and how they could be improved in their connectivity and in their service to their city. Specifically, we've done an analysis of the police department and our partners from the TUS group. You can see Mr. Jargal Saikan Dukar presenting on the right-hand side. He's explaining the model, but within their analysis, they have been able to produce some identification of inconsistencies within the police force. They've identified old rules that should probably be updated, and they've identified several opportunities to partner data and decrease the workload for that municipal police force in order to help them do their jobs better by working through the analysis process. So that was very exciting. And we have also partnered with the city of San Diego in California to help them address homelessness. So we have been just doing a little bit of work with them over the past few months, and we are following our recommended process. So we are using the driving mission statement, so the common mission of the city, and decomposing that with the stakeholders, understanding the individual stakeholder missions, and then coming up with what metrics supporting homelessness would be associated with specific stakeholders related to homelessness. So using this process, we have been able to compare the San Diego stakeholders, which you see the City of San Diego organization on the left-hand side, and it's a big org chart, but what you can see there are several different departments and several different groups within those departments that are organized to support the city services. And we compared the services provided within the City of San Diego to our recommended stakeholder list and acknowledgement, identifying that stakeholders come in 2 categories. There are beneficiaries who are receiving the goods or services from another stakeholder, and then service providers. And beneficiaries and service providers can be both back and forth. So the service providers include social systems, natural systems, and advanced complex systems. And we've iterated how those stakeholders fit within those groups. And so with the City of San Diego, we paired up the resources that the city had. And it was really enlightening. Just this small drill with the municipality resulted in acknowledgement that the city has a resource that they had not been using. So within the city, there is a San Diego Regional Data Library that had not been used by the city staff or other homeless service providers. And this regional data library is there for the purpose of consolidating and collaborating with service providers like the homeless providers to share information. And so we offered this was just a few weeks ago actually that we offered this. So the city is now working with a paid consultant firm to help identify the stakeholders within the community, get the data from those stakeholders. Now, homelessness stakeholder may be a shelter that has beds available for people when they're homeless and in need of temporary shelter. But other service providers, say the hospitals, don't have awareness of how many and where beds may be available in some of the shelters. And so in reality, a homeless person may be serviced in a hospital and be treated, and the hospital will call the one local shelter to find a bed and not see any beds available. However, if the data was shared in a consolidated portal, then that hospital would be able to see where beds were available and make a better recommendation to that homeless person on how they can better get to a solution and temporary housing. And so this data sharing is really a very complex challenge within the homelessness space. And I'm really excited, the city was really excited that we were able to identify this just with some very, very initial evaluation of walking through our process of identifying the stakeholders. So it was really, really great. We will keep working with them. We're now continuing to recommend metrics that city departments involved with homelessness could use to help understand how their services are being provided. So that's our application with the City of San Diego. We are also working on developing our reference architecture, and this has been really exciting. We have been working with the IEC, the International Electrotechnical Commission, on developing a reference architecture for smart cities. And as they are technical and electrotechnical, the IEC group is very focused on the lower level connectivity between data and ports and some of the communication techniques specifically within the smart cities support networks. And so we're working with them to bring the systems perspective and have a top-down perspective where we understand some of the needs of the users and the stakeholders and how those stakeholders may be interested in interacting with a smart cities reference architecture. And more recent news, I'm also really excited about this. We have also recently begun a partnership with the Salzburg University of Applied Sciences. And this particular, they have a Smart Cities Working Group that has tested out domain-specific systems engineering and applied that domain-specific systems engineering concept to developing a reference architecture for electric vehicles. So they have, through the Research Center, a partnership with Bosch and their neighboring communities, and have started setting up a case study for infrastructure service for electric vehicle charging, which is a great use case. And through this, they were able to identify and develop several different architecture models that will help us accelerate our architecture definition and keep it within those domain-specific languages. I'm sure as systems engineers, many of you recognize that if you're in an industry where systems engineering is not the prominent applied technology or process, that it can be difficult to explain MBSE models and how they're used and what all of the terms mean. So by shifting the language slightly to be more applied for the domain and tailoring that language, initially this seems to be getting some really good traction and some really good application. So we're very excited about this partnership. And you can see from this graphic right here how many different stakeholders there are just for this one particular instance. And we've got ISO requirements, and we've got architecture reference models, we've got BIM technologies, and we've got 3D models that are using graphic and geographic information systems. And then we've got, of course, the technology and people who want to use all of these different models that are put together. And so that language definition really becomes the center of focus for conversation about how do we start to develop this unified architecture. So we're really excited about that new partnership, and we're looking forward to continued collaboration with that team. And then finally, my last example I want to share with you is a use case model that we've developed without our architecture. We understand that we're working forward, but we wanted to understand if we could use MBSE, if we could use a model to help understand and describe a common situation that happens for municipalities. So we chose the homelessness use case and developed a model around this. Matthew Howes, through SSI, took some personal time and developed this. So our use case is that we have a city that has increasing number of homeless people that live in various places within the city, and it's caused crime and police interactions, problems with the residents, and decreased tourism. This is not a real city, but these are common things that happen when homelessness is prevalent. And in addition, homeless people are dying for various reasons, and the city administration wants to look at how to resolve the problem. So this was our use case that we did for practice to understand if our modeling efforts may be beneficial. And so when we look at a modeling diagram, we can see that the unhoused person at the center of the diagram has a lot of different organizations, factors, and parts of the city and non-governmental organizations to deal with in order to help resolve their issues. And so just looking at this, you could see pretty quickly how overwhelming this situation could be to an unhoused person. And so understanding this and even looking at this graphic has been really helpful. We showed this to the city of San Diego, and there was immediate understanding and feedback that this is illustrative of the complexity of the situation, and we haven't even gotten to any root cause analysis yet. So if we walk through our process, we would start by setting the initial goals. And so for the demonstration of this model, some goals were set up to improve the resident experience, provide environmental leadership, provide shelter, provide a safe environment, ensure financial health, provide addiction treatment, and permanent housing. So we just chose a selection of some goals so that we could identify how those would be traced through the model. And then we took a look at the causes of homelessness. And as we look at this model, I definitely want to remind everyone that we are not trying to model humans. We certainly cannot model humans. We don't want to model humans, but we do want to understand some of the factors around the human so that we can start to unpack and support resolution of some of the challenges as best we can. So we defined some of the causes of homelessness, defined some of the organizations that are involved with addressing homelessness, continuing to walk through the modeling process, and identified some of the situations, both positive and negative events that could happen in a homeless person's life. And those all came and were able to help define this state diagram, where we can now trace some of the virtuous and vicious cycles of homelessness, and things that may take people from being housed to being unhoused, and what are the paths that they have to get back to being housed. In this case, it's particularly interesting because in this sample case, there was not a way to move from being housed to getting addiction treatment without becoming unhoused first. And so this was a really alarming bit of information that we were able to develop, just coming out of looking at this particular model. So that was enlightening from our sample. In the interest of time, I'll just go through these, but you can see there was quite a bit of modeling that was done. And in the end, we were able to identify that some of just working through the model is helpful to understanding some of the causes of homelessness, major events in the cycle of homelessness that can happen. And there are so many different scenarios, but walking through the process can really be enlightening to help identify weaknesses, strengths, and lack of connections that may exist within the city in order to help bridge those gaps and really provide support for the humans that are in the city. So that was our demonstration sample. I would love to talk with you some more if you have any questions about what I said, about our initiative or what we're doing. And we would love to have you join us at any time. We always meet on the first Thursday of every month at 11 a.m. local time, your local time, which is UTC -3. So I would love to have you all join us next month on December 4th, actually in a couple days. We're going to continue developing metrics for the city of San Diego and looking at their stakeholders and how we can support them by using our systematic process.
Thank you, Jennifer. It's very exciting initiative. So to understand the complexity that involves to become a smart city. So very interesting. So Natalia, you have questions here?
We don't have any question in the chat, but I have a question for Jennifer. So Jennifer, when you mentioned that the first thing is to define the scope and the boundary of what you mean by a smart city, I imagine that it somehow has to be integrated with a greater part of the city. The examples that you showed, just like San Diego and you know other cities that may have parts that are not interconnected or don't have all the functionalities of a smart city, but you're integrating something that is. So how is that integration, and how do you see the unintended behaviors or emergent properties that may arise from the relationship of the smart city part with the environment, which is the non-smart city part?
Yeah, that's a great question, and I think some of that lack of integration is what has been frustrating for some municipalities in trying to institute smart cities. And so our approach really is to start from the top level at the city and identify the roles and responsibilities and identify really the goal for each of those subsystems within the city. And by just doing that step, by just defining what those roles are, really helps to clarify some boundaries that so there could be two conflicts, right, from that lack of integration. It could be that there's a redundancy or a duplication of effort that is not being reconciled, or there could be a gap in what's in services that are being provided, right? And so identifying those boundaries facilitate the collaboration between the departments or the teams providing that. And so we're really focused on that much higher, almost policy level within the city, rather than really the technical integration of say a smart sewer system with the integrated signals perhaps that may be in a road. So we're not at that level, because that is that's an application level, and there may be opportunities for crossover. But first, it's so important to start at the top and to decompose the mission, the goals, and the objectives for each department, and so that the departments understand how they can work together. And for the example that I just gave, there's probably very little correlation between a smart sewer system and a smart signal connection system. And there wouldn't need to be. However, there should be a connection between the smart sewer system and stormwater overflow and stormwater planning. And so joining those two would be of great value and worth the time and effort, because that those two systems would work together and have shared connection. And oftentimes the stormwater management department may be a different group than the sewer system connection. And so understanding that municipal or regional collaboration is really the first step. And once we recognize that that exists, well, then it's almost I can't say trivial. It's not trivial, but then you work through the process to figure out how to actually do the integration. But first, let's figure out if there's a benefit to doing the integration before we invest all the time and energy in coming up with what could be done.
Okay, thank you. Great answer. I have a question here from Fabio Silva. He says, great presentation, Jennifer. Thanks. How do you see the challenge of using systems engineering on influencing public policies? And how easy or difficult is the approach to government officials being a group of engineers? Any lessons learned from the initiative so far?
Fabio, thank you for that question. And Fabio is working with us with the city of San Diego. So yes, so we've had several lessons learned. And the first, if you would allow me to go back a little bit, this graphic in particular has been a huge success with some municipalities and some governmental people, and with others, they hate it. They don't want to see it. They don't understand it. It looks too complicated. And so the communication piece is such an important part of helping people understand. And while we recognize that we know the complexity, when we're communicating with communities outside, we really have to focus on one particular recommendation, on one particular step at a time, and we as systems engineers, we love the big picture. We want to know everything that's going on, and that has not gone well so far, to be honest. So we've learned to scale it back, to really take it step by step. And we've also learned how important it is to have good, fast feedback. Systems engineering is a risk avoidance, right? We don't have an immediate return on investment. We make things better, we make it safer, we make it less risky. And so demonstrating that value quickly has been really important in kind of the process, which is why for the city of San Diego, we quickly shared with them about the regional data source, that they should tap into that, when, you know, intuitively we would have wanted to come up with a little bit more robust solution and provide some metrics at the same time, but simply giving the feedback that we've identified this potential new partner has gone a long way to building trust. And they see value in investing the time with us because they're getting something out of it. And so giving a quick value has just been so important in working with the municipalities that we have been.
All right, we have time for one more question. This is from Carlos. What is your impression about including social issues in smart cities in contrast with the interest of technological players and cities administration?
Yeah, that's such a challenge, Carlos. Thank you for that. And certainly that's the reason that we focused on the 9 fundamental human needs, is that smart cities applications should solve a problem. And the problem should be one that the city's facing. And maybe it's a technical problem, but the social problems are even more challenging to solve. And we really feel that by using our process and focusing on those fundamental human needs first will help draw out a common theme for the city, and then help focus everyone on what the problem defined is, so that the solution can derive out of the problem. We are not just trying to apply technology that may or may not be a solution for what the problem is. So that's our whole approach, is really just try and turn the lens the other way, and start looking at what are some of the social challenges we want to solve, and how can we use technology to do that. So it's our focus.
Thank you, Jennifer. It's very inspiring to see systems engineering being applicable to subjects like, you know, social systems and, you know, problems that we have. Now I think that Ricardo wants to make some final considerations, but again, thank you very much for your presentation and for sharing.
Thank you, everybody.
Thank you, Jennifer. Thank you for sharing. It's a very exciting subject. So thank you again.